Continuing along, looking at some more circles. We're used to seeing circles with looking like this, the x minus h squared plus the y minus k squared equals the r squared, which means I've got an x squared plus a y squared term equals the radius squared term. And that's generally what we want, is because it's easy to graph, it's easy to see the radius. However, it's not always given to us that way. Sometimes it's given to us where it's all foiled out and messy, like in the next view. So what we're going to do is we're going to force it to look the way we want. How are we going to do that? It's something you learned back in college algebra. It's called completing the square. And what it means is we're going to force something to be a perfect square so that it will look like this with parentheses and something squared. But notice we need a square for the x's and a square for the y's, which means we're not going to have to complete the square once, but actually twice, so that we can actually get a perfect square for the x's and a perfect square for the y's. So let's just go ahead and dive in and try one, because that's going to be our best bet. So let's go ahead and try problem A. In problem A, we've got an x squared plus 8x plus y squared minus 6y plus 16 equals 0. So the first thing that we want to do when we're completing the square is we want to kind of separate our two parts. We want to keep our x's together as kind of one part of our problem. And then we also want to keep our y's together as the other part of our problem. Anything that doesn't have an x or a y is going to be a part of our radius, so it needs to move to the other side. So this 16 that's kind of dangling off by itself, we're going to move to the other side by subtracting 16 from both sides. At least for now. It gets us away from that, and now I can just focus on my x's and my y's. So I'm going to leave my x squared plus 8x. I'm going to leave some space, and then I'll leave my plus, and then I'll have my y squared minus 6y, and my equals negative 16 will be on the other side. Now, do not panic if you are worried about whether or not we're going to have a imaginary radius or a square root of a negative once we look for the radius. Not necessarily. Completing the square is going to require us to do some operations to both sides of the equation, which means that that negative 16 may not actually stay a negative. So let's see. So there are two steps to completing the square. It says once we're looking at completing the square, we look at only the x's, and we're going to take the number that's out in front of the x term, not the x squared term, just the x term. As long as there is just a 1 on the x squared term, we'll go ahead and just jump to completing the square, which means to take the number that's out in front of your x term, which here is an 8. And the first thing that you do to complete the square is you cut it in half. So we'll take the 8 and cut it in half first. Cutting 8 in half means dividing it by 2, which will get us a 4. The second part of completing the square says to take what you just got and square it. Well, if I square my 4, I'll get a 16. Now the question is, what am I supposed to do with that 16? Well, what completing the square says is I want to add my 16 in along with all these x's I was just working on. So I'm just going to add a 16 over here in with my x's. But mathematically speaking, I can't just add 16 to one side of the equation without also adding it to the other side of the equation. Now the question is, why did I do this? It's so that now, when we go to factor the x squared plus 8x plus 16, is it will factor out as a perfect square, meaning two identical copies. Because here's why. If you go to factor this, what two factors of 16 add up to 8? Well, that's two positive 4s, which means that this guy over here will factor out as an x plus 4 times another x plus 4, which can be rewritten as x plus 4 squared. Now the problem with this is we're not done. We still need to do the same exact concept all over again, but for the y's. So before I do that, though, I don't want to lose this. There's a plus sign in between my x's and my y's here, so I'm going to bring down that plus sign. Now we need to complete the square for the y's. So let's see. So I need to, again, make sure that there's only a 1 out in front of the y squared, which there is. And then I need to look out in front of the number in front of the y term, which is a -6. And it technically doesn't matter if you bring the negative along with the 6 or not. You'll see why in just a second. So we'll take our -6, and the first step, just like before, is to cut it in half. Well, half of -6 is -3. The second step is to take what you just got and square it. Here's why it didn't matter if you grab the negative. If you square a negative or a positive, it doesn't matter which, you'll still get a positive. So -3 squared gives us a +9. What this +9 is again, remember what I want to add in with my y's here. So I'm going to add a +9 in here with my y's, but again, once I add my 9 on one side, remember, our equation has to remain balanced. I have to add a 9 to the other side as well. Can't just do it to one side without doing it to the other. So let's see what happens. I've got my y squared minus 6y plus 9. And remember, the goal was that this should factor out as two identical copies, a perfect square. So I need two factors of +9 that add up to a -6, and that's going to be a -3 and a -3. So that means we'll factor out as a y minus 3 times a y minus 3, which I can rewrite as a y minus 3 squared. Now let's continue. We do have our equal to here. Continuing to read my equation. And on the other side, the question is, what's going on? Well, here's the problem. We added and subtracted quite a bit to the other side. So the first thing that we did was we moved the 16 over, and it became a -16. But then when we completed the square with the x's, we added a 16, so those two will cancel. And then we also added a 9 when we completed the square for the y's, so that would just leave us with the 9 there. So there is our official equation for our circle here, if I rewrite it. It's an x plus 4 squared plus a y minus 3 squared equals 9. So my question is, when I've got a circle, what's my center? Well, if it's a circle, my center is, here's my x value and here's my y value. Remember, we take the opposite. So if I see a +4, I'm actually going to take a -4. I see a -3, so I'm actually going to take a +3. And also, I need my radius here. Remember, the 9 is a part of your radius, but your radius is already squared. So my radius is going to be just the number 3. So this is a regular circle, because nothing weird happened, with a center at -4, 3, and a radius of 3. This is a circle. Let's try